Hello, we are going today to go over some pretty basic Lewis structures just to get an idea for how this process works of making a Lewis structure in the first place. Nothing too advanced or fancy. We're not going to do ions or multi-centered things, just these pretty basic ones. We're going to go through CH4, CO2, and NH3, one by one. So CH4 first. Let's do this guy. Remember that in a Lewis structure, you never want to put H in the center because it can only form one bond. So it's not a very good center because it can't have things around it. The natural candidate for this is to have the carbon at the center. So we'll put the carbon here, and then you can put 4 electrons around it because it has 4 valence electrons. Next, I'm going to put the hydrogens around it, which each have 1 valence electron. It's kind of handy to have the different colors because it lets you show what each electron belongs to. The blue electrons belong to the carbon, and the red ones belong to the hydrogens. Remember that whenever there's a pair of electrons between 2 atoms, that is a chemical bond. And you usually show a chemical bond by erasing the pair of electrons themselves and drawing an actual line. So I'm going to get rid of the pairs around here, and I'm going to replace it with lines. There you have it. That's CH4. The reason you know you're done and there's nothing more to do is the carbon has its 8 electrons around it. In other words, it has an octet, which is the number of electrons that it wants. It wants 8. Hydrogen is happy with just 2 because it has such a low energy level. It's so high in the periodic table, like right up at the top, that it only needs 2 electrons to be happy. All right, let's do the next one. CO2. Well, I bet you can guess which thing is going to go in the center. That's right, it's the carbon, because carbon with the 2 oxygens on either side of it is the most natural choice here. You don't want to put an oxygen in the center because then you've got it's almost like a symmetry sort of thing, where the oxygen in the center would cause the carbon to be on one side and the other oxygen on the other side. When carbon can go in the center, it should go in the center because it has those 4 lonely valence electrons that are just begging to be turned into chemical bonds. So I'm going to put carbon at the center here, and it'll have its 4 valence electrons around it. Next, I'm going to put oxygen. I'll put 1 on either side. You can draw 1 above and 1 below, or 1 to the left and 1 above. It doesn't really matter, but just pick 2 spots for them to go. Oxygen, we know, has 6 valence electrons, and you can get that by counting along the periodic table. So I'm going to give it 1, 2, 3, 4, 5, 6 on the left-hand side, and then I'll just repeat that on the right-hand side. 1, 2, 3, 4, 5, 6. This is a little bit more complicated because even though I can erase these pairs and replace them with a chemical bond, nobody's happy yet because the carbon in the middle has an electron up here and an electron down here, and it also has 2 electrons in each of those bonds. That's only 6 electrons. So carbon only has 6, and if you look at the oxygens, they are each deficient as well. Carbon right now has 6, and the O's, the oxygens, have 1, 2, 3, 4, 5, 6, 7 each. Remember that the bond counts toward both of them, and it has 2 electrons. So right now, the oxygens are both hungry for 1 more electron, and the carbon is hungry for 2 more electrons. Now, you may have seen this movie before, and you know what's going to happen. Hang on, let me clean this up a bit. Get all this unnecessary garbage out of here. Oh, I didn't finish writing this. The O's each have 7. Here's what's going to happen. The oxygens can use these electrons, which are all lonely and hanging off to the sides, to build more bonds between themselves and the carbon. When you get more bonds, that means that each of the atoms involved in that bond gets more electrons. So I accidentally erased an electron. That happens a lot. What's going to happen is that this electron and this electron are going to get together to make a double bond. Likewise, this electron and this electron are going to get together to make a double bond. What this ends up looking like is this. I'll get rid of those single electrons that used to be hanging out at the edges there. I'm going to replace them with these bonds. These bonds came from one contributed from the oxygen and one contributed from the carbon. Why do they do that? It's because it makes the whole molecule actually work. Now the carbon has 4 bonds around it. It has 2 double bonds, which is a total of 4 bonds. Each bond is, 2 electrons. So 4 times 2 is 8. So now carbon doesn't have 6 anymore. Now it has 8. Look at the oxygens. They each have 2 electrons up above and 2 down below. And they have 2 in each of the bonds, but they have a double bond. So it's 2 plus 2 plus 2 plus 2. That's also 8. Each of the oxygens have 8, and now they're happy. So this is the Lewis structure for CO2. Next, we'll be doing NH3. Obviously, this doesn't have a carbon, so we can't say, oh, you make the carbon the center. But what you can do is like rule out the hydrogen as the center, because it cannot be the center of a molecule, seeing as it can only form one bond. So the natural center here is going to be nitrogen. Let's put that in the middle. And if you count along the periodic table, you'll see that nitrogen has 5 valence electrons. I'm going to put them around nitrogen. Make sure to fill up these 4 spots before putting any more. I'll just choose to put the 5th one on the top. You could have chosen left, right, or bottom. It doesn't matter. But once I choose a place for that extra electron to go, now it's made clear where I can form bonds. This one, and this one are available for bonding because they are currently unpaired. The pair of electrons at the top of the nitrogen, or if you chose to draw it somewhere else in another position, maybe it's on the left, the bottom, the right, it doesn't really matter. But the pair of electrons that I've drawn at the top is not available for bonding because they're already paired together. So you can't fit another electron there, but you can in these 3 circled places. So I'm going to take these 3 hydrogens. I'll take one right there, one right there, and one right there. See how the hydrogens each bring 1 electron to the party. That's what hydrogen does. So I'm going to erase the pairs of electrons now, not because they don't exist anymore, but because they've become chemical bonds. The end of every Lewis structure is a quick check to make sure that each of the atoms in the structure is happy. So I'm going to do nitrogen. How many electrons does nitrogen have? Well, we'll count. It's got 2 up here, plus 2 here, plus 2 here, plus 2 here. That's 2 plus 2 plus 2 plus 2, or 8. And nitrogen is happy. So nitrogen has 8. What about the H's? The hydrogens each have 2. This is not bad news because hydrogen doesn't need 8. Hydrogen needs 2. That's what it needs in order to be happy. So this arrangement means that the Lewis structure is done and it's correctly drawn. You could also have done nitrogen with the hydrogens coming off the right, the top, and the bottom with the 2 over here. Or you could have done nitrogen with the spare pair on the right and the hydrogens coming off in the other directions. Or I don't really have room to do this, or you could have had the spare pair on the bottom. But you probably see that it doesn't matter which way you do it. It just matters that all the atoms form the bonds that they're supposed to. All right, hope that was helpful. Listen, if you want help with your class, you make sure to give me a call or a text at 617-966-3198. You can also visit my website at sntutoring.com, and we can get set up for you to get help with your class. Have a great day. Bye-bye.